Hello everyone, a warm welcome to our channel ICSE Insights. Today we are going to start a new chapter, that is chapter 1, force. So let's get started. The very first question which comes to our mind is, what is force? So force is a physical cause which either changes the shape or size of the body, state of rest or motion of the body, or the speed or direction of the moving body. And if we talk about the SI unit of force, so SI unit of force is Newton. The SI unit is Newton. And if we talk about the CGS unit of force, so the CGS unit of force is Dyne. Yeah, the CGS unit of force is Dyne. And if we talk about the relation between the CGS and SI unit of force, so it is one yeah 1 Newton is equals to 10 to the power 5 dyne. Yes, 1 Newton is equals to 10 to the power 5 dyne. And force is a vector quantity. Yes, force is a vector quantity. Many of you will be asking that what are vector quantities. So there are two types of quantities: scalar quantity and vector quantity. Scalar quantities are those quantities which have which have only magnitude. Scalar quantities are those quantities which have only magnitude. For example, 1 kg. So here there is only the magnitude, not the direction. Whereas the vector quantities are those quantities which have both magnitude as well as direction. For example, uh, 1 meter per second towards east. So here we have the magnitude as well as the direction. So it is a vector quantity. And if we talk about the examples of scalar quantity and vector quantity, so the example of scalar quantity will be mass, time, temperature, angle. Here we don't mention the direction with them, whereas the examples of vector quantities will be velocity, force, pressure. Okay, now our next topic is translational motion. Translational motion, or linear motion, or rectilinear motion. From the name, as the name suggested, we get to know that the motion is in a straight line path. Okay, for example, a man pushing a box. Here this man is pushing this box, so the box will move in a straight line path. Okay, the box will move in a straight line path. In translational motion, when a force is applied on a stationary or rigid body, in a translational motion, when a force is applied on a stationary or rigid body, the body starts moving in a straight line path, and this motion is called translational motion. Another type is rotatory motion. And in rotatory motion, when a force is applied on a pivoted body, then the body moves about the pivoted point, and this motion is called as rotatory motion. For example, uh, the wheels of your bicycle. The wheels of your bicycle or any other vehicle are pivoted from one point, from one point they are pivoted, and when we apply force, so they move about their pivoted point. When we pedal the bicycle, so the tires move about this pivoted point. This is its pivoted point, and the tire moves around its pivoted point. So this motion of this wheel around its pivoted point is known as rotatory motion. Another examples will be the motion of your fan, motion of a ceiling fan. It moves uh, around a fixed point, and the rotation of earth rotates on its axis. These are the examples of rotatory motion. In rotatory motion, there is a topic, moment of force or torque. Moment of force or torque is defined as the product of magnitude of force and the perpendicular distance between the line of action of force and the axis of rotation. So, first of all, let's understand the meaning of some technical words which are used here. First of all, we will understand what is perpendicular distance. So, perpendicular distance is the distance between the pivoted point, this pivoted point, and the point at which the force is applied. The point at which force is applied. So, the perpendicular distance between these points is uh, known as perpendicular distance. Another word is line of action of force. So it is the point where the force is applied. In case of this bicycle, we are applying the force here. So at this point, this is the line of action of force. Okay, and axis of rotation, the pivoted point at which the around which the body rotates, it is the axis of rotation. The SI unit of moment of force is tau. The SI unit of moment of force is tau. This is the symbol of tau. Tau. And the formula to calculate torque is force into perpendicular distance. Force into perpendicular distance. For example, a man is riding a bicycle. A man is riding this bicycle and he applies a force of 10 Newton. He applies a force of 10 Newton, and the perpendicular distance between this line of action of force and the axis of rotation is 5 meter. So the torque will be 10 into 5. That will be 50 Newton meter. Yeah, 50 Newton meter. Here Newton meter is the SI unit of torque, and CGS unit of torque is Newton centimeter. And the relation between the SI unit of torque and CGS unit of torque is 1 Newton meter is equals to 10 to the power 7 dyne centimeter. Sorry, here I had a mistake. I had done a mistake. Here, not Newton, dyne centimeter. Yeah. Now there are some factors affecting torque, and those factors are magnitude of force. Yep, the very first is magnitude of force. Magnitude of force. So how the magnitude of force affects the torque? Suppose a force of uh, 10 Newton is applied and the perpendicular distance is 2 meters. So the torque will be 20 Newton meter. And if the magnitude of force is increased. Let's say now the force is acting 20 newton, and the perpendicular distance is same, 2 meters. Now the uh, torque will be 40 newton meter. See, there is a vast difference between them. Here the torque is 20 newton meters, and when we increase the force, the torque is 40 newton meter. This is how the magnitude of force affects the torque. Another factor which affects the torque is the perpendicular distance between line of action of force and the axis of rotation. Yes, the perpendicular distance also affects the moment of force. Suppose a force of 50 newton is applied on a body. Just wait. Yeah, a force of 50 newton is applied, and the perpendicular distance is 10 meter. The torque or the moment of force will be 500 newton meter. And if the perpendicular distance is reduced to half, so the moment of force will get changed. Yes, 50 newton, and uh, we have reduced the perpendicular distance to half, so the half of 10 meter will be is 5 meter. Now the torque is 250 newton meter. See, and in decreasing the perpendicular distance, the torque also get also decreased. This is how the perpendicular distance also affects the moment of force. Now another topic is anti-clockwise movement. In rotatory motion there are two types of movement: anti-clockwise movement and clockwise movement. The anti-clockwise movement and the clockwise movement. This is our anti-clockwise movement. Yeah, this is our anti-clockwise movement, the movement opposite to the hands of a clock, and this is a clockwise movement, the movement in the direction of the hands of a clock. The magnitude of anti-clockwise movement, we consider the magnitude of anti-clockwise movement as positive, and the magnitude of clockwise movement is negative. For example, uh, let's suppose this is a wooden plank. Sorry. Yeah, yeah. If we apply the force upward, so this wooden plank will rotate in this direction, and this is a anti-clockwise motion, the motion opposite to the hands of a clock. Yeah, and if we apply the downward motion, yeah, sorry, if we apply the force downward, the now the plank will turn in clockwise direction. Yes, in the direction of the hands of our clock. It is clockwise motion. Our next topic is couple. Yeah, couple. A single force applied on a pivoted body. Couple is a single force applied on a pivoted body alone does not cause rotation of the body. The rotation is always produced by pair of force. In simple words, we can say that couple in couple, two equal and opposite forces not acting along a same line form a couple. Two equal and opposite forces acting in opposite direction. For example, suppose this is a cap of a water bottle, and when we have to open it, we put one finger at this point and one at this point, or at this point, and one at this point, and we apply equal and opposite forces from this finger in this direction and from this finger in this direction. So this is a case of a couple. Here two equal and opposite forces are acting. The magnitude of force is same, 10 Newton. Here also 10 Newton. And but the forces are acting in different direction. It is acting in downward direction and it is acting in upward direction. So uh, it is a couple. Another examples would be turning a key in a lock. While opening or closing a lock, we turn the key using our two fingers. Now we will study about moment produced by couple. Yeah, we have uh, earlier we have studied moment of force. Now here we will study about the moment produced by couple. So let's suppose this is a wooden plank, okay, and one direction, and we are applying force from here and from here. One force is acting in downward direction and one force is acting in upward direction, and it is the point where it is pivoted. It's the point from where it is pivoted, and the total distance between total distance total length of the this wooden plank is d. Since it is the center, so uh, the distance from the center to this force will be d by 2, and from this to this force will also be d by 2. For calculating moment of force, we will be using formula F into perpendicular distance. So force is F and perpendicular distance is d by 2. Since the movement of the wooden plank is in clockwise direction, so we will write here clockwise. Yeah. And for the another force, the force will be F and the perpendicular distance will be d by 2. This is also in clockwise direction. Yes. So let's this as equation 1 and this as equation 2. From equation 1 and 2 we can take F as common. Yes. And uh, D into. So equation 1 is F into D by 2. It will be of minus since it is a case of anti-clockwise, so minus. Now again here minus F into D by 2. So minus minus get uh, added, so F into D plus F into D by 2. Here we can take F as common, so F in braces 2 by 2 plus D by 2, sorry, D by 2. To add them we will take LCM, and after taking LCM the result will be this, and 2 and 2 will get cancelled, So the formula to calculate the moment produced by couple is F into D. While calculating the moment of force, the formula was F into perpendicular distance. But while calculating the moment produced by couple, the formula is F into D. So that's all for today. We will continue this chapter in our next video. Thank you.